Welcome to today's class. So in today's class, we'll be looking at matrices. So before I start, don't forget to subscribe, comment and share the video if it was helpful. So before we try and solve these questions, we are going to see and understand what matrices are so that you can solve this question simple. So to begin, what are matrices? So in simple terms, when you are talking about matrices, these are just an arrangement of numbers in rows and columns. So what do we mean? So whenever numbers are arranged in rows and columns, they look like this. So whenever we are talking about rows, we are considering this line which is horizontal. So this horizontal line is known as rows. Then this vertical line which goes down is known as a column. So these are the two things which you need to understand as you are starting matrices. So after understanding what rows and columns are, we are going to look at the order of matrix. So what is the importance of the order of matrix? So whenever we are talking about the order of matrix, so the order of matrix, this is an arrangement to which a matrix is arranged. So the arrangement of matrices differs from matrix to matrix. So our arrangement or how you should be writing your order of matrix is that you start by writing the number of rows which you have, then you multiply it by the number of columns. So when we have rows and column in one, that is known as the order of matrix. So an example I can give you is this one. So we have matrix A, which has 1, 2, 3 and 4. So if they tell you to state the order of this matrix, you are going to count the rows first. So you are going to say 1, 2. So you are going to say 2 times. Then again you count what? The rows. So we said that these are the rows. So you have 1, 2. So again you say 2. So meaning this is a 2 by 2 matrix. So just like that, we can again have a matrix which looks like this. So if you look at this matrix, again applying the order of matrix, we can see that this matrix has how many rows? 1, 2. How many columns? There's only 1 column. So this is a 2 by 1 matrix. So just like that, you can have different matrices with different orders. So now, how does this order of matrix help us in solving? So the order of matrix help us in a sense that we have matrices which are known as equal matrices. So what do we mean when we say equal matrices? So equal matrices, these are matrices which have the same number of order. So it can either be a 2 by 2 matrix with another 2 by 2 matrix. An example I can give you is we can have A, B, C, D, and we can also have another matrix which can have E, F, G, and H. So if you see, both matrices are what? Are 2 by 2 matrices. So we say that these matrices are equal. And when matrices are equal, meaning A is equal to E and B is equal to F and C is equals to G, just like that. So this is the meaning of equal matrix, meaning at each position of matrix A is also equal to the same position at matrix B. So after understanding the order of matrix, we have also looked at equal matrix. We are going to look at one example which we are going to apply the principle of equal matrix to solve the equation. So the question is, given that the official language. So this is the question we are going to be looking at. Yeah, so the question is saying, given that A matrix A is equals to 2x plus 1, 4, 5, and 10, and matrix B is 9, 4, 5, and y minus 5. So the first step is to write the order of the matrices. So matrix A, we can see that it has how many columns? It has how many rows? It has 1, 2. So matrix A has 2 rows and how many columns? Also 2. Then moving on to matrix B, how many rows and how many columns? It has the same rows and column, which is 2 by 2. So once you have identified the order of matrix, you can say now that A is equal to B because these are equal matrix. What did we say about equal matrix? They have the same order of matrix. So now since A and B are equal to each other, you are going to get the same matrix and equate them. So you say matrix A is, you write here 2x plus 1, 4, 5, 10 is equal to matrix B, which is 9, 4, 5, y minus 5. So after doing this, you can now equate each position to matrix B. So we said that this position is equal to this one. This position is equal to this one. That's why you can see here we have 4 and also here we have 4 because they are the same. Then when you come to this position we have 5, meaning here also we should have 5. So meaning if we have 10 here, meaning your answer after subtracting here should give you what? 10. And here also it should give you what? 9. So now since we have these are equal to each other, you can say now 2x plus 1 is equal to what? 9. Then you can go again and say 4 is equals to 4. Again, you say now 5 is equals to 5. Then you move on to 10. You say y minus 5 is equals to 10. So here you have equated now the two matrices. So now here our goal is to calculate the value of y and the value of x. So meaning these two are not important. So you pick the first one. You say 2x plus 1 is equals to 9. Then this, since 1 and 9 are like terms, you are going to group the like terms on the same side. So this one will close the sign and become negative. So you have 2x is equals to 9 minus 1. We have 2x which is equal to 8. Then when you divide by 2, you get your answer to be 4. So meaning x is 4. So if you want to prove if this matrix is equal to, if you replace 4 where there is x, you have 4 times 2 which is 8 plus 1 which is 9. Meaning this we have 9 and here we have 9. Then moving on to our second equation, you again say y minus 5 is equals to 10. So since 5 and 10 are like terms, so you are going to group them on the same side. So you're going to say y is equals to 10 plus 5. So y is equals to 15. So meaning our y is 15 and our x is 4. So if you replace y where there is, if you replace 15 where there is y, you get your answer to be 10, which is in matrix A. So this is how you can solve equations using the order of matrix. So whenever you see equation which have an equation inside of it, just know that you should apply what? Equal matrix. Yeah. Then another thing which you need to understand about equal matrix is that you can only add matrices again if they are equal. So we can go back to our first example here where we have A plus B, C plus D, E plus G, and F plus H. So how can you add this number? So he said again, you add the same position. So the way we are equating this is the same way you should be adding also. So if we are equating A to E, meaning if we are adding the matrices, you just say A plus what? E. Again, if you are subtracting, you just say A minus E. So this is how you can subtract and add matrices. Okay, so now that we have understood how you can add, how you can use the order of matrix to solve equation, and also how you can subtract. So the next thing is now multiplication. How can you multiply matrices? So multiplication is different from addition and subtraction in the sense that multiplication you should have the row and column of the two different matrices should do match. Why are we saying that? Because in multiplication we are multiplying rows with columns. So just like the way matrices are arranged, or just like the order of matrix, that is how we also multiply matrices. We can have an example which can be x and 2 and we also have 1 and 10. So is equal to 15. So remember, you can also use what? Multiplication to find the equation. So I said you multiply rows by column, then the results you add them. So plus, so after multiplying rows and column, the product you add. So what do we mean? So we are saying you multiply row by column. So we said, since this is a row, so we are going to multiply it with this column. So we are going to say x times 1, we have x, plus, you move on to the next row. You say 2 times 10, which is 20, is equal to 15. Then x is equals to 15 minus 20. X is equals to negative 5. So this is how you multiply matrices. So I've covered multiplication, addition, subtraction, and the order of matrix. So now moving on to our final part of our matrix, which is the important part for you to now solve paper 2. So basically what we have been doing, all these things, you will apply them in paper 1. Now looking at things which you come across in paper 2 are the determinant and the inverse. So these are the two terms, or these are the two things which you come across in paper 2. So how do we calculate the determinant and how do we calculate the inverse of a matrix? So again, you need to understand the way matrices are arranged. So everything on matrix is on the arrangement. Just know how rows and columns are arranged, because everything starts from the arrangement. So again, going back to our arrangement, we have A, B, C, and D. Then if you are told to find the determinant of this matrix, how do you find a determinant of this matrix? So a matrix has what are known as what? A major and minor diagonal. So a trick which can help you to remember is this line is the major and this line is what? The minor. So if we say we are finding the determinant, we are saying the major diagonal minus the minor diagonal. So we are saying that A times D should be subtracted from what? B minus C. B times C. So this is the formula which we use to calculate the determinant. So don't worry, you understand in the example. So the example we have is we have matrix A, which has 2, 4, 6, and 8. So we are told to find the determinant of matrix A. So how can you find the determinant of matrix A? So you say determinant, we say that you multiply the what? The major diagonal. So in our case, what is the major diagonal? So the major diagonal is the first number. So just remember by the first number. So we say 2 times 8 minus 4 times 6. So here we have 16 minus 18. I mean minus 24. Yeah. So if you subtract 16 minus 24, you find your answer to be 8 as your determinant for A. So this is how we calculate the determinant of the matrix. So now that you have understood how we calculate the determinant, how now do we calculate the inverse? So I started by teaching you how to calculate the determinant because the inverse is related to the determinant. So how do you calculate the inverse of a matrix? So this is the final part. So the inverse of a matrix is given by 1 over the determinant times adjoint of A. So what do we mean when we are saying adjoint? So an adjoint is a set which is opposite from the normal set. So what do we mean? So an example, if we have, let's take the same A. So if we say find the adjoint of A, you are going to swap these numbers in the major diagonal. So you are going to say 8, 2. Then in the minor diagonal, you are going to add negatives. So we are going to say negative 6 and negative 4. So once you add the negative in the minor diagonal and swap the major diagonal, you have an adjoint of A, which you can use to solve the inverse. So we can use this as an example. So since we have the determinant, we also have the adjoint, we can find what? The inverse. So you can say the inverse of A is equal to 1. What was our determinant? Negative 8. What is our adjoint? 8, negative 4, negative 6, and 2. Then here you can multiply. So our inverse therefore is negative 8 into 8, we have 1. Negative 6 divided by 8, we have 2 over. We have 3 over 4. Then 2 over 8, we have 1 over negative 8. Then here we have half. So this is the inverse of this matrix. Then when you multiply these two, they should give you a matrix which gives results like 1, 0, 1, 0, which is an identity matrix. So when you multiply the inverse and the what? The normal set, you get an identity matrix. So those things are not important. So what is important is what I've taught you here. How to find the inverse, how to find the determinant, how to multiply, how to use the equal equation in what? In matrix, and how you can know the order of matrix. So these 4 principles are what you need for you to solve any question on matrix. Then coming on to our final part, which is the revision part. So we have 3 questions here. We have 2 questions from paper 1, and we also have 1 question from paper 2. So I'll basically solve only 1 question here. Then the rest you can solve them, because we have talked about the equal matrix, how you can find x if you have equal matrix, how you can multiply 2 matrices, and how you can find what?